Should be live. Let's see. We got some stuff to do today. Take a quick double check. This is just, yeah, silly group chats. Let's take a quick look through, see what's new here, and then we'll get started on some dev. Holy. Okay, so we got Xander's N. I think I'll do this review. Hi, how's it going? Welcome. Just catching up real quick on what I've missed since yesterday here, and we'll see what I'm going to do at the moment. Okay, Bet's got Blaster here. This is just set up. Some silly formatting errors. Some support, okay. I'll get this working very easily. Okay, this is just them trying to figure out how to do sweeps. New video from Bet on Blaster. It's funny that it like goes up to like RAM stuff. I think I just saw a bug. Wait, 4, 5? Did you see that? Oh, maybe that one just has more health. That one look any different? Yeah, that one does look different. Okay, so maybe that one just has more health. Cool. I think we're set here. I look at Xander's N at the moment, and we'll see how that goes. Okay, so we have this open, cool. And where is, yeah, it's this one. What's the latest here? 2 days ago. Wait, did he push this? Oh yeah, no, it would be 2 days ago, right? Yeah, okay, this is good. So this is going to 2.0-dev, that is fine. One change requested. It's fine. And let's take a look and see how this works. That's a good thing to do with the morning. It's Let's see what Xander added. Um, SFault. Well, that shouldn't even be possible. We literally have tests. We have this sanitizer. It shouldn't even be able to SFault. Okay. No big deal. Well, now it doesn't SFault. Here's the end. We definitely need to make like some sort of little grid engine at some point. I'm fine having people do their own like dedicated things for now though. These appear to be random. So if I run this, oh, you know what? The SFault might just be on my end. I have some weird display things. That's fine. This seems like it works. Cool. So let's take a look. First of all, these are, I believe these are just the normal Raylib dependency SFaults. Mem leaks. These are fine. So good job there. What are you doing? I'm currently reviewing and integrating a new environment in 2 lines. I'm integrating a new reinforcement learning environment made by one of our contributors at the moment. Let's see if we can watch it. It's like this collection, like trash, like pick up and deposit environment. New gym env? Not quite gym. Compatible with gym, yes. But these are in Puffer API, so these will run about 1,000 times faster than anything that you see over there. If you haven't seen our demos, you can play all of them right here. Here's a MOBA. And we have all these different environments. They're all ultra fast. Snake. Lots of fun stuff. Let me add him. Yes, this guy's Xander's. Oh, he actually... Wait, use pre-trained... Okay, this is set to false. So he has the model, but it's not trained and integrated, it seems. Okay, so can I just do... First of all... Okay. Puffer, was it trash? Pick up. There you go. Okay, so we have some speed issues here. We'll see why. Basically, new Puffer M should never ever have 20% time spent on the environment like this. So this should be like 800, like 750, 800 steps per second train. And with optimization, we should be able to get this to 1,000,000. Just curious to know an easy way to implement from RayLib. So standard seems independent learning, an easy way to match IDs to policies. What is it? Really? Oh, that's you? Oh, cool. Yeah, so we're planning that stuff for January. You're welcome to help actually if you'd like. We have it basically, we had something that we implemented that's just not being used and hasn't been updated at the moment because like it was an extra layer and we weren't really using it for much. But like when you're training at 500,000 to 1,000,000 steps per second, a lot of these problems that seem hard are just suddenly very, very easy. Now, if you have like a research reason for fundamentally wanting to do separate policies and stuff, that's totally understandable. And there are ways to hack it in the current implementation, and then there are things we can do to support things better. And that will be coming in January. Like one thing you can do is just reshape the batch in the forward pass, right? And then send it through different subnetworks. That's a really easy way of doing stuff. Definitely take a look at our environment code though. Like things can be made much, much simpler. Oh, I also just shipped yesterday a much easier way if you're trying to port like a Python environment to Puffer. I added a much easier way to do that and still get a lot of our speed ups. Not as much as in C, but still get a lot of the speed ups. You can look at ocean/pi squared now for the Python version of our squared test environment. Need to get into this, not computer scientist, just applying RL for logistics. Oh, if you're applying RL to logistics, then I can almost guarantee you that whatever problem is not going to need like fancy separate policy stuff. If you're in academia, we're very happy to support stuff for free. All Puffer is free and open source. If you're at a company that is trying to do this stuff and having trouble, I would also point you to we do have service packages on our website. But all our stuff's also free and open source. So you're also just more than welcome to hang around and ask questions and use stuff as it is. That basically just gets you custom features if you need them for your specific application. Eyes on your problem, etc. Is this working? I can't tell if this is training. Finishing PhD? A-okay then. Free support. We're very happy to support academia. I just finished my PhD up myself last spring. Yeah, okay, so Xander, I don't think that this thing is quite working the way you would expect it to be working. Let's figure out why that is. CTDE is common approach to multi-agent, I would say. It is the common approach, but it's overbuilt. You really don't need it in a lot of cases. My specialty in my PhD was multi-agent, and generally IPPO is just tremendously effective when applied quickly. So if you have a slow sim, then maybe you look into fancy algorithms. But if you're doing stuff in logistics for which you can build a fast simulator, it's going to be tremendously more effective to just apply the simple method really, really fast. For context, my PhD, I built what is probably the most complex multi-agent set of simulators out there. Like, this is the newest version of it. This is a full MMO with like an inbuilt economy system, leveling, items, equipment, like 1,000 different agents in the same environment. They run for like hours and hours. We've trained policies for like 2,000 years worth of simulations in this thing. So, I can tell you a thing or two about multi-agent learning. And I am very much aware that CTDE is very common. It was even common back when I started this stuff in like 2018, but a lot of it can be replaced just by making things go fast. And it's a lot simpler to do that as well. The other thing is CTDE doesn't even imply separate policies. You can still have the same policy per agent and then just share the value function. That's a little bit easier. I would suggest looking into that, if anything. Maybe something to consider. And it's also really for team-based stuff, where you train that as well. It's not really for adversarial or like free-for-all settings. All right, let's see what Xander did. 4 agents, 1024 environments. Okay, so he did this correctly. Batch, mini batch. Ooh. Is this mini batch good? I think this is actually good, right? I forget what the max is before GPU starts to degrade. I think I tested this. Okay, so it is 32K, so he's fine. Report interval is too big or too small. Okay, so that doesn't make it any faster. And it does make the metrics slow to report, so we try 32. Okay, I don't know what's up with this report interval. I guess it's because all the M's are synced up. How old are you, sir? 27. Newly minted MIT PhD. Finished last spring. Now working full-time on making reinforcement learning actually work properly. And building a small company around it. All free and open source code, though. Let's see what Xander did here. Something screwy. He messed with this parameter, which I'd advise not doing, but he didn't mess with it very much. He was running sweeps, so presumably it's not that. Wait, is this batch size sketchy? 4096. No, I think that's still, that's 16 or 32. 130. Wait, oops. 1, 2 over 32. No, not over that. What is it? Over 4096. Yeah, 32. I'm right. Okay. That should be fine for this environment. Yeah, my lambda look reasonable. Is the curve going up at all? Let's pull up logs. Welcome, YouTube folks. We're currently integrating Xander's new environment. I do full code reviews and I help with integrations for all contributed environments. So if you're looking to get into RL, it's a really great way to get started. We generally have people like start off by building a new env. It's a really good way to get familiar with Puffer and all the stuff that we work on. And then I slowly onboard people onto the science side using their experience with building at least one environment themselves. All right, let's see if we can figure out what's going on here. So, need a few more data points. Come on. So, losses here. This is fine, this is fine. Entropy is kind of low. Value is good. Value is very good. Suspiciously good, even. So nothing sketchy there. This just looks random with variance to me. Did Xander... Hold on, I thought that he committed some stuff. I thought he said that he had this working. It's working, I think. Yeah, he has it here. Local 2D. Pushed everything up. Try to find tomorrow. Alright, some settings. Put this one doesn't defaults. Does he have only used with local 2D crop, but I don't see a bool here. I don't even see the option in here. 2D crop space. I don't see anything egregious in here so far. What policy is he using? Custom policy? Okay, so you don't need to do this because your model is literally the default here. So this is just going to be whatever it is, recurrent. That's just redundant though, that won't fix anything. And then what you do here, you have a conv with a lot of channels. I don't see anything terrible here either. Oh, is it learning? Wait, what was the x-axis in this thing? Maybe it is learning. Yeah, that's like weird. Yeah, that's bizarre. Because this is a very simple environment. Probably there's some stuff wrong. Okay, so it is learning. So I suspect then that there's just something crazy going on with this policy. $600 lines. Very simple end logic, it looks like. Oh no, because these call, okay, he made like subfunction for stuff, that's fine. So, total trash, not collected. There's no reward here. Where does he put this? Where did he put stuff? Message is too long, we'll post in Discord. Yeah. I'm pretty responsive there. I mean, this is mainly the point of streaming, right? Is that I can like engage with people that are looking to use stuff in Puffer, have RL problems, merge contributor code. I also do the dev, like my own personal dev live, just because why not? But you know, people do watch it. We've got 4 on YouTube, 1 on Twitch at the moment. The peak has been 20. Take a while to get back to that. Okay, so here's the compute observation function. This is what I wanted to see. So num cell types, empty trash, bin agent, right? Iterate over site range. Check if cell is within bounds. One hot encode. Wait, obs index plus plus. I don't think this is a one hot encoding. I think he just has the obs wrong. Because this is like you're setting the current index to 1 or to 0, but you're not. Okay, I think the encoding is screwy here. Let's see what you did here. Come on. $485. So what is 485? Agent site range times 2. Agents. Okay, so this is a crop with 4 channels. So that actually is the correct one-hot encoding dimension. What is the agent site range? Is it 5 by default? Yeah, so self observations 0 dot shape. Well, wait a second. That's 40. Self.numObs. Oh, plus 1. Okay, so this is 0. That looks weird to me, right? Hold on. Oh, I found your thing. I think my use case CTD often makes sense. Because why should I train different policies for the same AGV type? So this is not what CTDE means, though. You can train the same policy without doing CTDE. This is what IPPO is, which is just standard PPO. You share the weights for the same policy and you apply them independently to each agent in the scene. CTDE sometimes has separate policies, sometimes has the same one. The defining feature of CTDE is typically that you're sharing at least the value function during the course of training, which can be useful for cooperative tasks, but we've had plenty of success without bothering doing that. Independent learning, if I've been... Yeah, so I think that you've got your definitions backwards, and actually the assigning policies to agent, it's doing the opposite of what you want in RLib right now. And the thing that Puffer is doing, if you have the same AGV type, is the thing that you want, and is the simpler thing, and is the faster thing. So I think that you just win here. Logistics is a great area to apply RL though. Let me see how he structures OBS. Marcel, yeah. So what we do, first of all, IPPO, PPO is the same thing. People just are making meaningless distinctions. The simplest, most common way to apply PPO in a multi-agent setting is to just treat each agent independently, like it's from a different environment, but using the same policy. So the same policy is used independently to compute the actions for each agent. This is the same thing as just concatenating all the agents into the batch dimension. This is tremendously effective in a wide variety of cases. Now, technically, for cooperative problems, right, what you can do is centralize the value function. So you can take all of the outputs from the different agents and use them in a single shared value function. But there are some subtleties that you have to take into account when doing that to get it correct, which, at least as far as I have seen, are generally not worth it. And I think that the vast majority of problems you will just solve immediately with our basic PPO, given how fast it is. If you train 100 agents, Agent 1 learns something from Agent 2, it's the same network. There is one policy. It's independently controlling each agent, right? So you have one neural network. That neural network computes the actions for Agent 1, computes the actions for Agent 2, computes the actions for Agent 3 independently. So this can be deployed, in plenty of real-world settings. So pretty much, this is the standard way you would do stuff in every real-world setting, really. You're training one policy. You're using all the data, right, to train that one policy. So it's very effective. Yeah, you're not training 100 separate policies. That's not CTDE though. CTDE is something different. CTDE, so here. Okay, so it depends heavily on your algorithm, but for like PPO, for instance, right? The main thing that you're training for reward stabilization is this value function. So you have like your policy, and then you get like action, ATN, not ant, and then you get reward, right? Not reward, hold on, value, okay? And then every single agent is going to produce these values, which is just like a batch dimension. Okay, so you just take this, you get your agent data right across all your agents, right? And then what you can do is you can either get a whole bunch of value functions, a whole bunch of separate values. This is if you do it independently. But what CTDE does is it takes like agent 1, agent 2, agent 3, agent 4, and they each are going to produce their own actions. But then they all produce one value. That's CTDE. And the reason this is CTDE is because you only need the value function at train time. So you're training them like together in aggregate on this one value function. But then when you deploy the policy, you don't care about the value function so that they still operate independently. And this is like kind of a useful idea, and it's been useful in a number of cases, but like vast majority of multi-agent problems, you don't even need this. If you just get a fast sim and a good implementation of PPO, you'll solve it the simpler way and save yourself a lot of headaches. You train centralized one policy and decentralized. If that's how people are referring to it, then they're mucking with the definitions. It makes far more sense to look at the value function specifically, because like it really doesn't matter if you train one policies or n policies. Like that has no implications on anything. The value function specifically is interesting because you only need it during training time, which is why you can centralize the training of the value function and decentralize the execution. You're not centralized training one policy though. That's a different thing. That's if you were to have one policy with like, let's say 5 agents on your team. It has 5 different action heads and it's jointly computing actions. That's not what is happening here. It is independently computing actions for each agent. People muck with the definitions, especially in multi-agent. Like if that's how they have it defined, that's how they have it defined, but that's not a useful definition. Because it's like, it's focused on something that's completely irrelevant, which is whether you're training one set of weights or multiple set of weights is completely irrelevant. The fashion of whether you are jointly computing actions and jointly computing values, or independently computing actions, jointly computing values, that is the thing that matters. Is that the new MultiAgent RL book? Centralized training. Yeah, but you're missing the key of the value function being shared. Like, it's not centralized training because you're training one policy. Like, you're always doing that anyways because you're sharing data across parallel copies of the environment, right? Like, you have different instances with different like agents anyways. That's just a batch dimension. The relevance, right, is that if you jointly compute actions, then you cannot deploy the policy independently. Each agent cannot just take its own data source. You need all the data for all the agents to deploy it. But if you only centralize the value function, then you can train centralized and then deploy it decentralized, right? That's the key distinction. Like I said, people might have mucked with the definition. What is this? Is this the new Morrow book? Oh, yeah, this was the new. I saw this and didn't like it. Right? Pelhams. No, it's not independent policies. I mean, and the thing is, like, this is like completely. I mean, this is like so out of touch if that's what they do, because nobody does that. Yeah, so I saw this thing and I saw the table of contents. This is insane. Like, this is 10 times more math than is ever relevant, and like a tenth of the engineering and like implementation detail that actually matters. So yeah, I don't necessarily recommend. Oh, look at this. They actually have right here. Well, this is actually very funny because these are very trivial environments, all of these. But 328, where is it? They literally have, see this hardware environment? We have a port of this in C that's like shorter than the original or whatever. You can play it online. Look, here. This is trained with PufferLib with our default policy, with nothing fancy whatsoever. This runs like 1,000 times faster than the original as well. Look how nicely they get out of the way for each other and like go find new boxes. This is trained in like a few minutes on one GPU. Very simple policy, very simple PPO. I didn't like the book because, first of all, these are not complex environments at all. So these are like trivial tasks. They did a ton of math on trivial tasks, which is completely irrelevant. Like, you can solve all of these trivially with like the simplest methods you can think of, and they completely omit any of the actually more complex tasks. Can I place obstacles there and the agents can collide? The agents can collide. I don't know if this one has obstacles, but like generally these things are very trivial to implement. Like, Rware is not one of our more complex environments at all. Like, Rware is, okay, to be fair, the Rware original environment has this really obnoxious, like, redundant graph algorithm in it for no reason. If you cut that out, then it is a very simple environment, and you can implement anything like this you want for your specific use case in like a day, and have it be 1,000 times faster than than anything that's being mentioned here. Like, I know all of these, or almost all these environments. Hanabi is cool. Overcooked has literally the worst code base I've ever seen. This thing is about probably 100,000 times slower than it should be. Smack is cool, but unfortunately really, really slow because it's stuck to the Blizzard engine. It's insulting to call MPE a complex environment. That's hilarious. And then, yeah, this is fine, but I wouldn't call it complex. OpenSpiel is board games, so not necessarily, I guess, kind of multi-agent. And then Petting Zoo, yeah, they have some. Yeah, I don't know. It's not like this is bad content. It's just like out of touch for how this work is actually done now. I can change grid and add walls. I don't know if we have walls, but like adding walls would be like a probably 30-line code change. What you're looking for is kind of like a grid-based engine. We've had a couple people mess with that. I tried to mess with that a little bit. You can definitely change the grid easily. That's just a custom map. That's trivial. I can ask Spencer about walls. That shouldn't be hard. I mean, here, I'll show you, like, for any of these environments, right? Here, let me show you, because I think you've been misled a little bit. I think you've been a little bit misled here. And I'm not mad at you. I'm mad at, like, people overcomplicating stuff for newcomers to, like, I don't know why people overcomplicate this so much. I need to know C. Okay, but have you actually read any of our C? It's like the easiest C you've ever seen. Okay, so the reason this is 800 lines is entirely because Spencer also ported this completely redundant graph algorithm from the original Rware environment. You can literally just ignore that. Like this whole like process, cycle, movement and stuff is like completely redundant. So yeah, the code looks like this. It's literally like ifs, it's just conditionals and loops. It's literally just conditionals and loops. So like, it's not any harder to write this than it is to write Python. I wrote Python for 10 years. Within 3 weeks, I was just as comfortable writing this. Now I think this is probably easier. I am not a systems guru. Yeah, so this whole thing, this whole block of code is irrelevant. All the cycle stuff is irrelevant. In fact, this trash pickup end is probably simpler to look at because this has 600 lines and doesn't have all the fancy stuff. So this is logging code, and then the actual code for the environment, we've got compute observations, we've got place random entities, we've got move agent. This is also more complicated than it should be, to be fair. Let me see if I find you like one of the M's that I wrote. Because like we have people from like a variety of different like engineering skill levels on these things. Let me think. Probably my snake environment would be a nice one for you. So this thing is only 350 lines for multi-agent snake, including this logging. There's initialization. There's your observation function right there. Here's like adding and deleting snakes. Very nice little snippets of code. There's spawning food. There's the environment reset. This is the step function. It's like one screenish of code, a little more than one screen of code. And that's it. Rest of it's rendering. Not so bad, right? I had this in Python before, and it's like about the same length as it would be in Python. We've got sample environments and tons of people in the Discord to help as well. I've also been converting major RL labs to this as well. We've got a collab with NYU. We've got one with MIT and one with Oxford as well on this stuff. So I'm not just making this up. Like this is, I promise you, this is very, very much simpler and easier than the other stuff out there. Like something like this environment here, you can train this at 1,000,000 steps per second and just automatically solve it. Dictionary with agent IDs? Nope, do not do that. If you do that, you are screwed because Python dictionaries are slow. But we have an easier way for you. Look, here, I can even show you, you can even start prototyping in Python without going to C, and it'll still be faster than RLlib to start with. So if I just look up squared pi squared, I added this yesterday. This is a pure Python version of a very simple test environment, right? So puffer pi squared. Here we go. Okay, so here, this is a very simple little environment that I wrote. This is just a random policy playing it. This whole thing is 100 lines of code, not even, in Python. It is way faster than the RLlib API. Reason being, it is a vector implementation. So this buffer here is going to actually be, is going to give you a nice slice of shared memory. And then when you write stuff into observations, you're going to be writing directly into shared memory. I get 1,000,000 steps per 1,000,000 steps per second training, even in pure Python. Of course, that's only for very simple M's. As the M gets more complicated, that's going to dip, and that's when you think about going to C. But you can prototype this in Python, work exactly as you'd like to. That'll probably be a very nice way for you to try out Puffer as well, and I can promise you it'll be faster than RLlib, because that library is hideously slow. You'll probably end up solving your problem in pure Python before you even have to touch C. And then you can go to C if you want it to be really fast. Well, step just takes, oh yeah, I didn't answer your original question. So it just takes an array of actions. So it's a vector API. So if you've got 10 agents, then you just give it, an array with 10 numbers, which are the actions. We also handle like multi-discrete spaces if you need those. But yeah, it's just a vector API. If you have to like dynamically add and remove agents, that's a little bit more annoying, but we do support that. There's like an extra mask field that you can update to like mask out dead agents. So there you go. I hope this helps. I'm saying this as somebody who wasted, like I literally wasted 1,000 hours of my time during my PhD trying to make RLlib work in like old versions of Neural MMO. It's a terrible library. I've tried many, many times to help them with it. The devs, they really were trying with it. It's just like the way that they built that library is not the way that things work in RL. Yeah. I think it'll take a lot less time as well than you might think to do this type of stuff, because like if you're used to RLlib, they have a giant blob of code where nothing makes any sense, right? And you have to really like look at the docs and then fiddle with stuff and whatever. We have a tiny, tiny amount of code by comparison, and it's faster, it is simpler, and it works on a huge range of problems. We have all sorts of high performance environments built in. This is what I'm doing full time, right? I'm making RL not suck to work in. I gotta get back to this trash pickup end because I want to make sure I get some progress on this. Let me see what the heck's going on with this. And don't let the C scare you. It's not scary. Like if you took one systems course as an undergrad, you're good. Heck, we have brand new programmers writing this stuff as well. Not this particular M, but others. Why is it? What's this extra observation? So the first scalar is this carrying status, I guess. Okay. One wall, hold on. One is trash, apparently. Why these? I'm screwy here. So what did you do? Out of bounds cells are -1. Okay. I wouldn't suggest that, but fine. Is this really how it is? It's like this line of trash here? I doubt that, right? Oh, actually, hold on. No, empty is... Something's not right here. Something's definitely not right here with the observations. So wait, you loop over agents, you loop over site range, and then I don't understand how this works. Obs index. Hold on, you know what? If this is wrong, then I would think gotcha, Xander. Your obs are wrong. Gotcha. So I see exactly what he did. So what Xander did here is he made the observations for one hot. So like he added 4 channels, but then in the code he's not actually filling it in by channels. So he's filling in like the first quarter of the data and then the rest of it's empty. Tisk tisk. So that's why it doesn't work. I guess I will... Should I just fix it for him or should I message him? Let me think. I got half an hour. I kind of, sometimes, you know, after I've done a few PRs, I kind of like to just fix people's stuff. Shows I'm not bullshitting. Let me see if I can just fix it real quick for him. Every once in a while. Let me see. So this is not a ×4, buddy. ×4. 4. Num cell types. Compute observations. Oh wait, is he? Did he? Wait, no, actually, did he do it right here? Hold on. What? Then why? Is this laid out correctly in memory? I can see the observations are wrong here. Maybe only for one agent? What did he do? I missed this loop when I was looking at it. Get out of here, bot. Subtypes. Oh, hold on. So if I do 0, 1, 2, 3. What if it's this? Oh, that's not it either. Okay, so if it's this, mostly empty, trash. I might have just been being stupid. Hold on. Bin is not. No, there is a bin. Agents. 11 by 11 by 4. I thought I saw it and it looked pretty obvious. I didn't see that there was a weird loop in a way I wasn't expecting. Okay. Let me try in the start of the network then. See what the heck is wrong with this thing. Actually, put it here. Oh, I think I see it. Is this right? Yeah, so this is an 11 by 11 that's supposed to be one-hotted, right? You can see this data is completely screwy. And the reason is permute. He messed this up. So it's like this. Permute. Empty. Alright, let's try this. I think I forgot to remove breakpoint. Maybe not. No? What do you mean no? CNN local crop. Five at stride 3, 3 at stride 1 is good. I actually see he was trying to print observations here. I don't think I'm wrong though, like something's very screwy with this. Mellow. Combine features. I guess that just means more stuff is broken. Let this run for a bit while I figure out. So that was definitely an issue, like the observations were definitely screwy. So yeah, that would completely make sense then, like why it would take forever to learn anything. So he's setting rewards and dones correctly here. Add reward. Well, that doesn't make any sense. Trash. Trash not collected. Something with the resets, I wonder. What does he do when he resets the env? Nulls the grid. Carrying? Does he null the entities? Okay, yeah, he overwrites them. So that should be fine. What's up with these rewards being so screwy, though? It doesn't make any sense for it to be so variable across so many environments. See if it's this. Log buffer. No, this is correct. So I can't fault him for most of this. Well, there's something screwy here. Has he played it? There's no human play mode here. Oh no, he does have this. Left shift. Oh, he doesn't have a no op is why, so you have to like I think you have to like hold the puffer to it. Okay, so I'm the red puffer. What? You can push the trash bin? Hold on, I didn't realize you could push the trash bin. It's amusing. Total episode reward is tiny though. I don't know what that is. But doesn't seem to be working. Okay, so it gets 0.5 every one it deposits, right? That seems better. Let's see if I can finish the environment, and let's see if it resets cleanly, because that's the other common. Another common RL bug is like you play your environment, but you don't actually check to make sure it resets cleanly. It's funny how you can actually grief by pushing it into a corner. Welcome, YouTube folks. Currently debugging this new contributor RL environment. It's kind of nice. It's just not working ideally yet. Does it not reset? Hang on. Does it only reset at 500 steps? I would break it. Yeah, I know they're holding it, but it says crash collected 20 out of 20. Okay, so it does reset. Oh, well, hold on. That's bizarre, right? So it does solve it. But it's just weirdly slow. Yeah, so they literally all have to drop the trash in. I bet you that's the issue. What did he have? Like 1.5K steps or something? The hell? Why don't I have... Did they change their UI? Ugh, this is gross. What the fuck? Where's the freaking thing to change the axes now? What is wrong with these people? X-axis. This doesn't do anything now. Okay, so 500 steps. So he had like 1.5K before. So I think I made his thing 3x faster, maybe. Yeah, more, because this is 2,000 steps, okay? So I had it, now it's at like 500 for solve. Let's see what this does. I'm still not happy with the 500 though. This is 400 million steps, which is way too much for this environment. It shouldn't take this long to get off the ground. Though maybe they have bad... Whoops, camera froze. Hey, welcome YouTube folks. Cool, first stream over 10 viewers in a while. So this was just like observations were incorrectly formatted. This is a bad transpose on the observations, causing this to not work before. Here you can see this one going up fast now. Let's see how long this takes. Now this one's not necessarily expected to get to 20 because it doesn't have enough time to solve the whole task. Let me explain my reasoning here. So if you give it 500 steps, right, it's going to get most of the trash early on. And then there's going to be like some puffers holding some trash or whatever. And if the environment doesn't reset, everyone else is just there twiddling their thumbs, waiting for new opportunities to get reward. So this is just like a really obnoxious learning dynamic in general. And the way to solve this immediately is to just like add a trash back randomly every time one is deposited. That will make it, way quicker. So I will let Xander know this. Let me see how well this does though first. Oh, it actually does solve it. Haha. In 100 steps. Let's watch that policy actually. 1400. Let's wait till we get a new checkpoint. $19.7. And then we'll watch this policy back, and then that'll be the morning stream for us. With this environment fixed, good feedback for Xander. I'll push these changes. You'll all be free to try it as well. Okay, 1600 gold. Pickup mode eval. Native. 6C. That's a little fast. I'll just, for now, I'll just add a little delay. I'm gonna wait for this to finish, and then I'm going to send him a nice gift. It's a nice policy. Hello, nerd. How's it going? Nerds rule, man. solved 200 mil steps. Your compute observations was missing permute. No, was it your, let's see, had observations order. Awesome. Good to see it dropping by stream. Push this for Xander. That's like a really satisfying policy to watch for whatever reason as well. What just happened? Oh, they're stuck. That's so funny. Okay, so there are some degenerate cases where they get stuck. That's so funny. That's reinforcement learning for you. It's really cool to see stuff like this work. It's like really basic, and yeah, you could totally just write a scripted method to do this, but it's still cool. Last thing I'm gonna do. Background. If steps were to complete were part of the score, do you think it would develop more complex coordinates so there are less collisions? It implicitly is. There is a penalty for taking longer implicit in the RL algorithm. Hey, Tim. Yeah, this is a contributor env. Had a couple bugs, just fixed them. Hold on, trash. This will be puff red, puff cyan. This is fine. This is puff red. Carrying. Red. Is this everything? Aren't there lines? Yeah. Trash pickup. We give it the puffer canonicalization. The lines are not good here. Hold on. The lines don't look very good. So let's do this. We'll leave his light gray. And then huh. RL-based chess engine? Probably. We have good vectorization, if nothing else. I gotta come up with another color for this. This is weird. Background 624. So let's do 50. There we go. Code immediately. Oh, I just messed with that. I think we'll do the other way around as well. This one will be puff cyan. And this one will be, whoops, red. There we go. And then the text has to be puff white. Oops. I don't like the there we go. I don't like that it's like let's do $15. Is this like a tint? Is there a way to just do this as a tint? No, there's not. I think what we can do is here. There we go. Now it's applied as a tint. Cool. Nice. Okay. I'm gonna go to the gym and get some brunch. I will be back streaming probably for a bit later in the afternoon, probably around 3:30 or 4. For new folks here, this is a project to make reinforcement learning fast and sane and pretty accessible as well. It's all free and open source. You can find more at puffer.ai. Please star the repository here. It helps us out a tremendous amount. We also have a Discord, 867 members at the moment. You can get fast help here if you're interested in doing some RL yourself or using these environments or adding some. Contributing environments is also the best way to get involved with Puffer and onboard yourself onto this space if you're new. I also post all about RL right here. You can get notifications when I'm live here too, because I stream on X, Twitch, and YouTube simultaneously. See, it's all RL content, not a bunch of BS. And other than that, I stream most of the development, and we've got big plans for 2025 for this project. So thanks for